Hi math students! This lesson today is going to be on how you multiply and divide with decimals. Before we get into the decimals, we have our two review questions this morning. The first one says, Kiani made $240 this week working 20 hours. How much money does she make each hour? Well, in order to do that, you would want to do 240 divided by the 20 hours. You're dividing the total amount of money by the total amount of hours to find out how much money she makes each hour. And when you do that, you'll get that she makes $12 an hour. For the second one, we've got Denise buys a dress for $24.75 and a pair of pants for $25. If she pays with a $50 bill, how much change should she get back? For this one here, there's going to be two steps we have to do. The first thing we want to do is figure out how much total money she spent. So I could take the cost of the dress and, let's not do what I did yesterday and write down the wrong number. The cost of the dress and the cost of the pants. When I write that 25, I want to make sure I'm writing it under the 24 so that we add those whole numbers together. And I'll change 25 to $25.00. When we add that together, you'll get $49.75. If she's paying with a $50 bill, you might be able to do that in your head and see that she's getting 25 cents back for her change. You could also set it up as a subtraction problem, like this, and get the change as well. Either way, she should be getting 25 cents back. Now that our brains are all warmed up and ready to do some math, we'll get started. Remember, we said this lesson here is going to be on answering problems using multiplying and dividing decimals to help us answer them. So to start off, I first want to look at multiplying decimals. And to help us know how to multiply decimals, I want to review what you already know about multiplying whole numbers. So in a moment, I'm going to have you go ahead and multiply this. Multiply it by hand. I know it's so tempting to grab that calculator, but we had said it in an earlier video, but I'm going to say it again here. Part of the focus in this class is to make sure you know how to do this math by hand. A lot of tests that might be in your future, such as the ASVAB, the AccuPlacer if you're planning on doing Ivy Tech classes, or certification tests. A lot of those tests, the math part, you don't get a calculator, so I really want to make sure you know how to do this by hand. So to review how you do it by hand, go ahead and multiply 41 times 23. Right, if you're multiplying that by hand, the way we saw in the lesson last unit was stacking them on top of each other like that. Start with this 3 here. We'll do 3 times 1, which gives us 3, and 3 times 4, which gives us 12. When we switch over to multiply the 2, you need to move over one place. So that 2 times 1 would go right here. Some people like to leave it blank. Other people like to fill in that space with a 0. But we've got our 2 times 1 there, and then the last part, 2 times 4, gives me 8, which would go right there. We've got 2 lines of numbers that we want to add together to find our final answer, which would be 3, 4, 9. So 943. You want to make sure you're feeling good about this because what we're going to be doing today with multiplying decimals is very similar. So the first example I've got is we're going to multiply 4.1 times 2.3. Now, one of the tricky things about multiplying with decimals is figuring out where the decimal goes in your answer. So before we multiply out, the first step I want us to do is estimate. If I wanted to estimate the answer for this, what you can do is instead of thinking 4.1 times 2.3, round each of these to the whole number. When I say round, I mean what is 4.1 closest to? Is 4.1 closer to 4 or is it closer to 5? Well, if that number right here after the decimal point is 4 or lower, we go down. And if it's 5 or above, we round up. Goes back to when you're thinking about where the number is on the number line. 4.5 is here. 4.1, 4.2, 4.3, 4.4 are all over here, so closer to 4. Whereas 4.6, 4.7, 4.8, 4.9 are all closer to 5. So if I wanted to round these numbers to help me estimate, I would say, well, 4.1 is closer to 4, and 2.3 is still going to be rounding down, so 2.3 is closer to 2. The easiest way to estimate these is finding the whole number each of those is closest to, and then doing the math with that. I know 4 times 2 is 8, so that's going to tell me 4.1 times 2.3 should be close to 8. I rounded these both down, so since these are both larger numbers, it'll be more than 8, but it gives me an idea where the number should be. It shouldn't be like 200. It should be close to 8. When we go to do the math, it's going to be very similar to what we did over here. I'm going to stack those numbers on top of each other and then multiply using the same process we did over here. I'm going to say 3 times 1 gives me 3. 3 times 4 gives me 12. Don't worry about the decimal point until we're all done. So I'm not going to try putting a decimal somewhere in this number. We're going to multiply the 2 next. So 2 times 1 gives me 2, and I'll fill in that space with the 0. The 2 times 4 gives me 8. And then just like before, I'm going to add it up and get 943, just like I did over here. Same process. The only extra step is figuring out where that decimal goes, which is part of the reason why estimating is so helpful. If I know my answer should be close to 8, I know the answer definitely is not 943. I need a decimal somewhere in my answer. If I put a decimal here, 94.3 is not close to 8. But if I put the decimal here, 9.43 is close to 8, which is how that estimating can help you out. The rule we use when it comes to where that decimal goes in your answer is you're going to count how many total digits are behind the decimal point in the problem. In this problem, there is 2 numbers that come after decimal points. So a total of 2 numbers after our decimal points. Our answer is going to show that. There is 2 numbers behind the decimal point. If instead of 4.1 times 2.3, the problem was 41 times 2.3, it's going to work out to be the same number. But then here there's only 1 number after the decimal point, which means my answer would have only 1 number after the decimal point. It would be 94.3. So you kind of get an idea there where the decimal point is going to go by counting how many total numbers come after the decimal point and making sure your answer has that many numbers after the decimal point. We're going to look at another example here in just a second, as soon as I erase the board. The other example we're going to look at is 4.7 times 3.8. Starting off here, we're going to estimate first. Go ahead and estimate what the answer is. Just like when we've estimated before, the answer is not, when you estimate, it's not going to be the correct answer. I'm not looking for the answer to this question. I'm just looking for an idea of around where our answer should be. Well, if I was estimating this, I would come in and say, well, 4.7 would round up to 5 because it's 0.7, which tells me it's closer to 5. 3.8, the same idea, that 0.8 there tells me I'm going to round up and say, well, 3.8 is close to 4. And then I'm going to use these rounded numbers to estimate my answer. 5 times 4 is 20. That tells me that 4.7 times 3.8 should be close to 20. Notice both times I rounded up, so these are larger numbers. The numbers we're actually multiplying are smaller, so it's probably going to be smaller than 20, but it gives you an idea around where our answer should be. Saying it should be around 20 means my answer shouldn't be 1,000, right? It shouldn't be 100. It should be around 20. Next step is to multiply 4.7 times 3.8. Go ahead and try that. Well, if we want to multiply these, I'm going to start with my 8. I'm going to say 8 times 7 is 56. Then I'm going to do 8 times 4, which is 32, plus my 5 gives me 37. Next, I'm going to multiply with my 3. So 3 times 7 gives me 21. Remember, we're moving over one place, so I'm going to put the 1 from 21 there and then carry my 2. 3 times 4 gives me 12, plus that 2 would give me 14. So I get 14 there. My last step, I'm going to add these together. We get 6, 7 plus 1 is 8, 3 plus 4 is 7, and then my 1 goes right there. Now the last part to this is, where is my decimal going to go in my answer? Well, I come back up to the problem. We've got 2 numbers after decimal points. There's a total of 2 numbers. So my answer is going to have a total of 2 numbers after the decimal point. I'm going to go 1, 2, and there's my decimal. We get 17.86. This is the last example I've got. There are going to be 2 word problems we look at now with multiplying decimals. Sorry, I couldn't find my eraser. So the last part of this is looking at what it looks like when you're multiplying decimals. Remember, we saw in our adding and subtracting decimal lesson, the most common place you're going to see decimals is money. You can also see decimals with lengths or measurements, temperature, weights. But money, I think, is safe to say that's the one that we're most familiar with. So I've got an example here with money. The information they give us is boxes of Cheerios cereal cost $3.50 at Kroger. And the first question asks, how much does it cost to buy 5 boxes? Go ahead and try that for me. Well, one way we can figure out how much 5 boxes cost is I can say, well, it's $3.50 for the first box, plus $3.50 for the second box, plus $3.50 for the third box, and keep adding. But we learned in our multiplication unit that the faster way to get that answer would be to do $3.50 times the 5 boxes. I want to multiply the cost of 1 box times how many boxes I'm buying. Using what we just did a moment ago with multiplying decimals, I can line it up like this. Now notice when I'm multiplying decimals, it's not like what we did yesterday with adding and subtracting decimals. I can put my 5 right here, and I don't need to line up my decimal points like we did yesterday with adding and subtracting. That's because when we were adding and subtracting decimals, the decimal in your final answer just came straight down, so I needed them to line up. But today it's different. The decimal is going to be wherever the total amount of numbers after the decimal is. So we don't need those numbers to line up like we did yesterday. I say all that to say it's totally fine for me to put my 5 right here. I don't need to write it as 5.00. So when I go to multiply this, I've got 5 times 0, that gives me 0. 5 times 5 gives me 25. 5 times 3 gives me 15, plus our 2 would give me 17. So we get $17.50. The cost for 5 boxes is $17.50. Now the second part to this question is, if boxes are on sale for $2.75 a box, how much money do you save if you buy 5 boxes? I'm going to have you go ahead and try this. There's actually 2 different ways you can get the answer to this question. So if you see this and you just know right away what to do, you're like, this is so easy. See if you can figure out both ways I'm thinking of to figure out the answer for this. All right, so when I read this question, what I would be thinking is, well, similar to up here, if each box costs $2.75 now, and we're still buying 5 boxes, let me find out how much this costs. And then if I want to know how much money you save, well, this is what I would have been paying before. When I multiply these, I get what I'm paying with the discount, and then I could subtract to figure out how much money I save. So let me show you. I'm going to erase this. I can do the $2.75 times 5. So the cost of a box times how many boxes I'm buying. That would give me 25. Here's 35 plus 2 is 37. And then 5 times 2 is 10 plus 3 gives me 13. That tells me when they're on sale, I would be paying $13.75. That is the sale price. This is the original price. So if I want to find out how much money I'm saving, I could just take the original price, subtract the sale price, and that's going to give me the difference. That's going to give me how much money I saved. So if I do that, I've got $17.50. I'm subtracting $13.75. Just remember, that goes back to what we learned yesterday. If you're adding or subtracting, you want those decimal points to line up like this. When I go to subtract, I can't do 0 minus 5, so I need to borrow and make that a 4 so that I can make this a 10. Then I can say 10 minus 5 is 5. 4 minus 7, can't do that, so I'm going to have to borrow again, change my 7 to a 6 so I can make this 14. And then 14 minus 7 is 7. And then my 6 minus 3 gives me 3. 1 minus 1 is 0. I don't need to put a 0 here, but I do want to bring down my decimal point. We are subtracting, and when you are subtracting, that decimal just comes straight down. So I get 375. What is that? Well, remember, we were subtracting the original cost and the sale cost to find the difference, which would be how much money I saved. So this is one way you can do it. You can say we saved $375. I know we saved that because I took away the sale price from the original price to find how much money I saved. The other way you can do this, and maybe you just watched me explain the way you didn't do it. The other way some people do this problem is instead of subtracting at the end, they subtract at the beginning. Instead of waiting until the end to find the difference, what you can do instead is say, well, this was the original cost for one box, but when they're on sale, they're $2.75. So we can subtract $2.75 to see how much you save on one box. Now, why would that be helpful? Well, if you know, let's say you save 25 cents on one box, then you could multiply at the end to see how much you save on multiple boxes. So here when I subtract, I'm going to have to borrow from the 5 so that I can make that 10. That gives me 5. I'm going to have to borrow again to make that 14, and we get 7. 2 minus 2 is 0, so we get 75 cents. This is telling me how much I save on one box. I know I'm saving 75 cents for each box I buy. So if I want to see how much money I save on 5 boxes, I could then do, well, I'm saving 75 cents for each box times the 5 boxes I'm buying. When I do that, 5 times 5 gives me 25. 5 times 7 is 35, plus my 2 gives me 37. 5 times 0 is 0, plus that 3 gives me 375. There are 2 numbers behind our decimal point, which means my answer needs 2 numbers behind the decimal point. Means our decimal point's right there. What do you know? It's the same answer as before. I really love this question because it's having you practice multiplying, adding, subtracting all at the same time, and there's different ways to get the answer, which I think is always important. There's not always just one way in math to get the correct answer. This is the last example I've got. There are some for you to try now. So let's get a clean board so you can see them. The first one I've got for you is what is 3.45 times 3.2? The next one is Adam makes $10.25 an hour and works for 7 hours this week. Isaiah earns $9.50 per hour working and worked for 7.5 hours this week. Who earned more money this week? And make sure you justify your answer. All right. I would argue that Adam is the easier one to calculate here. We're doing the $10.25 an hour times 7 hours. When you do that, you get 35. 14 plus 3 is 17. Here is 1 and 7. So he made $71.75. Isaiah, we are multiplying how much money he makes per hour times how many hours he worked. He worked a decimal for an hour. This is like saying he worked 7.5 hours. When we go to multiply, I'm going to multiply with my 5 first and get 4750. When I multiply with this 7, remember I'm putting a 0 there, and then when I multiply these, I get 0. I get 35, and then 9 times 7 is 63, plus that 3 gives me 66. I've got 0, 5, 12, 11, 7. When it comes to deciding where the decimal goes, we've got 1, 2, 3 numbers behind our decimal point. Means my answer needs 1, 2, 3 numbers behind our decimal point. 1, 2, 3 numbers behind our decimal point. Now we're talking about money. $71 and what is that, 250 cents? That doesn't look quite right. When you're talking about decimals, if you have a 0 at the very end of the decimal, that is not needed. So this is really $71.25. Once you know that, you're able to say who made more money this week, and I would use these numbers to help me justify. This is the first part. This was multiplying decimals. There is a second part, which is on dividing with decimals. So to help us talk through this problem here, I've got Jalen gets lunch with his 3 friends. The total bill came to $21. They decide to equally split up the bill. How much will each person have to pay? What would the equation be for this problem? Well, lots of students, when we do this in class, say, I see equally split up. That tells me we want to divide. I agree, we are dividing up that bill. Well, what's the bill? $21. Awesome, so we want to divide the $21 by 3 people. I see 3 friends, so we want to do 21 divided by 3. That's easy. Not quite. How many people are eating? How many people did that $21 come from? We've got Jalen and his 3 friends. There are 4 people here. Tricky, tricky. So we want to do that 21 divided by 4, which isn't as easy as 21 divided by 3. 21 divided by 3, that divides equally out. That's $7 each. 21 divided by 4 doesn't divide as equally. When I go to divide my 21 by 4, we've done division problems similar to this before. We would say, well, 4 goes into 21 5 times. 5 times 4 is 20, and we get remainder 1. And in the past, when we did this, we would say our answer is 5, remainder 1. Or if it was a word problem, we usually said like 5, and then there's 1 left over. In this problem, though, what are we talking about? We're trying to find out how much each person will have to pay. If we got a bill for $21 and we divide it up, that 5 is telling me each one of us has to pay $5. But what's remainder 1? That means there's $1 left on that bill that you have to pay. You can't just tell the restaurant, hey, we couldn't divide the 21 up equally between us, so we're just going to pay $5 each, and don't worry about that last $1. You can't do that. You have to divide the entire thing. There can't be anything remaining. So the way we're going to do that is instead of using a remainder, we're going to use a decimal. When we talked about things you can use with decimals, money is one of them. Now it's going to be important to decide based on the situation, can you have a decimal? If I was dividing 21 people, I wouldn't want to use a decimal. I don't want to say, and there's 0.5 people, but it's money. You can divide up money and have a decimal. So in this situation, we would want to write our answer as a decimal. Now, how do you do that? Most people just say, 1, so it's 0.1. It's not the way it works. What we're going to have to do is think of what 21 would look like if it did have a decimal. Well, that's $21. We know $21. You can say 21 like that, or you can say $21.00. So to help us get the answer as a decimal, I'm going to come in and say, let me put 0.0 there. That helps me because now I've got another number to divide with. Now I can keep going, and now I can say 4 goes into 10 how many times? Well, 4 goes into 10 2 times, so I can put my 2 up here. Now notice I put the decimal right here in our problem. That's going to be the same spot the decimal goes in our answer. I've got 4 goes into 10 twice. 2 times 4 is 8, which means there was a remainder of 2. Same as before, we said you can't have anything remaining. You have to pay that entire bill. We're looking for a remainder of 0, so we got to keep going. I'm going to come in and put another 0 here. That's going to give me another number to divide by. We can say 4 goes into 20. 4 goes into 20 5 times. 5 times 4 is 20, which would mean the remainder is 0, and we are done. So what do we get for our answer? How much will each person have to pay? We've got each person pays $5.25. Now with these word problems especially, there's a way you could check. How could you check to see if this answer makes sense? Well, think about it. If each person pays $5.25, does that mean they're going to end up paying a total of $21? Well, if 4 people each pay $5, that's 5, 10, 15, that's $20 right there. And then if each person pays 25 cents, 50 cents, 75 cents, that's $1. So you've got your $20 plus the $1 means they paid the $21. You can do it in your head like I just did, or you could actually multiply this out to make sure that it equals $21. This was one example for you. I've got 2 last ones, what it looks like if it's not a word problem, if it's just you dividing 2 numbers using long division. Now that we've seen dividing with remainders and dividing with decimals, I'm going to need to tell you which way I want it. So I'll either tell you I want you to divide and write your answer with a decimal, or I'll say I want you to divide and write your answer with a remainder. So word problem, you're going to have to figure out like we did in that last one. Here though, I want to write my answer with a decimal. I'm just going to start off dividing like we normally would, using long division. This part here hopefully is a review since we did long division in our last unit. If you need a refresher, you know that you can always go back and rewatch those videos. But our first step would be how many times 5 goes into 6. 5 goes into 6 one time, so that 1 goes up here. You can go ahead and if you know what the remainder is, you can write it down, or you can say 1 times 5 is 5 and subtract to find the remainder. Once you've got the remainder, you bring down the next number and you go all over again. So you say 5 goes into 10 2 times. 2 times 5 is 10, which means the remainder is 0. We bring down the next number and do it all over again. So 5 goes into 8. 5 goes into 8 one time. 1 times 5 is 5, which means the remainder is 3. This up here, up to this point, this is what we had been doing in the last unit. We were saying 608 divided by 5 is 121, remainder 3. But because I'm saying I want you to write your answer with a decimal, that's going to be where we do the new stuff we learned today. In order to write it as a decimal, I want to change 608 to 608.0. That helps me out because now I have another number I can use to divide. I'll say 5 goes into 36 times. So I have my 0.6 there. 6 times 5 gives me 30. And we're left with remainder 0. That's how I know I'm done. And I've got my answer, 121.6. We write down the zeros one at a time because depending on the numbers you get when you're dividing, sometimes you only need 1 0 to finish dividing. Other times you might need 2 or 3 zeros. So just put them in one at a time. If I had gotten a remainder here, let's say I had like remainder 3, that's when I would put in another 0 and keep on going. There's one last one here. Go ahead and try this one for me. All right. If you divided that, you would have said 10 goes into 75 7 times. That would give you 70 and a remainder of 5. You bring down your 9 and you say 10 goes into 59 5 times. That would give you 50 and a remainder of 9. To get our decimal, I'm going to put in a 0.0 there. And then my last step, 10 goes into 99 times, and we get 75.9. The last ones I have for you to try are number 5 right here. Tiara bought 18 inches of wood to make a picture frame for her mom. She needs to know where to cut the wood to make the frame. She wants to make a square picture frame. How long should each side be? Go ahead and try that. The key to this one is knowing what you're dividing. I know this is how much total wood she needs. She's trying to make a picture frame, a square picture frame. So she's trying to take that total amount of wood and make a square picture frame with it. Well, she's gonna need wood for each of those 4 sides. If you didn't figure that out earlier, go ahead, pause the video now and and find out what the answer is. Once you know it's gonna be 18 divided by 4, that's gonna tell you how long each of those 4 sides are. When I go to do that, I've got 18 divided by 4. I can say 4 goes into 18 4 times. 4 times 4 gives me 16, which leaves remainder 2. I can put in my decimal there and then say 4 goes into 25 times because I put my decimal there. That's where my decimal point is. And 4 goes into 25 times. 5 times 4 is 20. We subtract and get 0. So I'm left with my answer 4.5. The question is, how long should each side be? So we're going to say each side should be 4.5. What are we measuring with here? Inches. Each side should be 4.5 inches. If I wanted to check that, well, if I'm saying each side is 4.5 inches, I should be able to add all of that back up and get the total amount of wood she has, which if you do that, you do get 18. This is everything I've got for you on multiplying and dividing with decimals. At this point, you have learned all 4 operations with decimals. The last lesson for this unit is tomorrow, and it's going to be on how decimals and fractions are related and how you go from one to the other. So get ready. See you guys. Bye.